Are we being controlled by a higher intelligence as if we were characters in a video game? That idea might not be as far-fetched as it seems. I'll explain coming up. Researchers at the University of Queensland have developed Cyborg Beatles.
Help, I need somebody.
Not those Beatles! I'm talking about the darkling Beatles. Ugh. Well, researchers have created cyborg darkling Beetles by outfitting them with microchip backpacks, enabling remote control via video game controllers. This makes the Cyborg Beetles perfect for search and rescue missions as they can navigate tight, complex spaces like disaster rubble. The Beetles' natural climbing abilities and sensory footpads give them a major advantage over small robots, especially when transitioning from flat surfaces to walls. The backpacks use electrodes to stimulate antennae, enabling directional control, including vertical movement. Early tests showed that the Beetles could climb even while carrying batteries as heavy as their own body weight. Isn't that cruel to the Beetles?
Dearest sunlight.
Relax. The researchers claim these enhancements do not affect the Beetles' lifespan, and future improvements aim to add lightweight cameras and power sources for better performance. And you need performance in your design, so let's check out a device that can deliver in our premier product highlight, sponsored by Mouser Electronics. Phoenix Contact's CRIMPFOX-RC 25CUS crimping pliers are designed for uninsulated cable lugs using indent crimping. Laser marked per customer specifications, they are part of a product line that includes CRIMPFOX-RC 10 and RCT 25-1. Covering both uninsulated cable lugs and insulated tube lugs. All models in this series feature an ergonomic design that reduces the crimping force required by 25%, enhancing user comfort and efficiency during repetitive electrical installation tasks. Check out these comfortable crimpers today by visiting Mouser.com or by clicking the link below. It's time to get a grip on automation. To explain, we present David's Corner.
Thanks, Andy. We don't talk about robots an awful lot, but they are a really critical component of a lot of automation systems, especially when picking and placing things repetitively. And there's two main types of robot grippers or end-of-arm tools. The first one is things that can pick up by creating suction, which usually uses a form of air pressure or a vacuum generator. And this vacuum generator, while running, uses the Venturi or the Bernoulli effect to be able to pull air in, picking up large sheets of product like sheets of glass or pieces of cardboard, boxes and palletizing. It's great for those kind of things. But if it's a very porous material or it just doesn't lend itself well to being picked up, another kind of gripper is the one that actually grips or grabs onto the side of the object. These can have 2 fingers, which they call a parallel gripper, but they can also have 3 fingers or any number of customized end effect tools to be able to grab products. Things like plastic bags, which would be very difficult for a vacuum. Large, odd-shaped objects. Now these two are powered by vacuum, powered by air, but there can be electric-powered grippers too, falling under either this category of vacuum or the gripper type, and we see these kind of applications in wide variety no matter where we need the application to be in industry. Andy, back to you.
Thank you, David. Are you a smart bite or smart bit? Let's find out in our control automation quiz, Smart Bit. Okay, in our Smart Bit quiz, you must match the right answer to its question in less than 3 seconds. The questions are scored using actuator output percentage, and today we'll be testing your knowledge on a robot mechanic named Boltron and an autonomous speed car racer. At the end, you'll see if you're a smart bite or bit. Let's begin with our first question for 25%. The autonomous race car enters the pit lane after a high-speed stint. Telemetry indicates slight brake fade and inconsistent steering response. Boltron begins a full diagnostic sweep. What is Boltron's most critical first action upon car arrival? Is it A, confirm wheel speed, steering angle, and brake temperature data to prioritize inspections? Or B, begin mechanical inspection immediately, relying on physical signs alone? And the answer is A. Confirm wheel speed, steering angle, and brake temperature data to prioritize inspections. Confirming key telemetry data first allows the robot to prioritize inspections based on real-time performance indicators, ensuring efficient and accurate diagnostics. Let's move on to our next question worth 25%. Voltron notices misalignment in the LiDAR sensor's pitch following light contact with another car. Obstacle mapping is skewed by 1.3 degrees. What is Voltron's top priority to restore accurate autonomous navigation? Is it A. Recalibrate pitch and yaw of the LiDAR unit to factory precision, or B. Restart the perception software and apply minor software corrections? And the answer is A. Recalibrate pitch and yaw of the LiDAR unit to factory precision. Recalibrating the LiDAR's pitch and yaw ensures precise navigation, as even slight misalignments can cause major perception errors that software alone can't fix. Okay, let's move on to our final question for 50%. Voltron stays in position 1 second too long and gets run over as the autonomous car peels out. What procedural failure led to the incident? Is it A. Voltron failed to clear the designated safety zone before vehicle launch, or B. The car sensors failed to detect the robot due to LiDAR occlusion? And the answer is A. Voltron failed to clear the designated safety zone, a critical procedural error that directly led to its own destruction. Well, how did you do? Are you a smart byte or bit? You can have another go at it right now by clicking the link on your screen. Thanks so much for tuning in, and we'll see you next time.